This is a lightning talk presentation of my final semester project for GSEM 5385 Photogrammetry at Texas A&M Corpus Christi, presented by Cockrell. I'm a graduate student there. And it's on the accuracy of two elevation data sets in Longview, Texas, where I used RTK GNSS to collect 30 ground test locations and determine root mean square error by the USGS LiDAR specifications vertical accuracy of the two data sets. The first data set was a national elevation data set, 2013, 10 meter, 1 degree block. It's produced by USGS as a continuous raster. I downloaded it from the Texas Natural Resource Information Systems for Gregg County. The second data set was the City of Longview Aerial Mapping Project prepared by Atlantic Technologies in 2002 that flew 147 square miles of the ETJ area. It was compiled with a Leica RC30 camera using Kodak film, black and white, a maximum flight altitude of 4,000 feet above ground level, had 19 flight lines flown between 10 a.m. and 2 p.m., which produced 510 images with a greater than 60% overlap, greater than 30% side lap, and there were 30 panel ground control points with continuous GPS data logging. And the Match AT software for aerial triangulation was used. The delivery was a DWG vector format of a 2-foot contour interval. It had classified layers to the City of Longview schema, like edge of pavement, edge of gravel, earth and dam, brake lines, to a 1-inch, 100 feet national mapping accuracy standard. In the contract, the RMSE will not exceed 1/7,500th of the above ground flight altitude. It also gave you the expected accuracy and the maximum tolerance, and I assumed that they didn't fly above 4,000 feet, so those numbers could be readily calculated. I loaded 12 panels from the City of Longview 2002 data set that stretched from the Longview Mall to the Judson area and back over to Spring Hill and across the Challenge Golf Course. And that's where I got my, that was the study area I did, about 4 square miles. I chose 30 test point locations. I wanted open view of the sky, an undisturbed area since 2002, really non-vegetated other than mowed grass. I wanted good accurate reads from whatever the aerial project got. I needed to be within radio correction range of my base station. And I wanted to choose locations that varied in elevations from the top of the ridges to some on the slopes and to low valleys, mainly just to test the NED 2013 DEM. Everything was projected in State Plane Coordinate System, NAD 83, Texas North Central Zone. That used the vertical datum, NAVD 88, and it was in U.S. survey feet. So there was a little bit of unit conversion with the NED 2013 data set in meters, but I imported all the 12 DWG panels into Traverse PC, and I also imported some quarter quad maps from Tenris to visually select the points, and exported out the XYZ coordinates of the City of Longview 2002 data set. I imported XY coordinates into Global Mapper, and when I exported those out, I assigned Z coordinates from the loaded Digital Elevation Model 2013. I then created a stakeout pnezd.csv file for my data collector field. I occupied City of Longview CSM 1208 monument, which was one of the primary control points for the aerial survey. It's well-established brass cap monument. With a Trimble R8 base receiver broadcasting corrections, Trimble R8 RTK, using G0812A, auto tolerance, 3 pop measurements, 5-second occupy, fixed solution. And I point staked everything within about 1/10 north and east, and then I stored a side shot. I used the root mean square error, which is basically your calculated point minus your observed point squared over the number of samples, summated, square root of that. And then if you take a square of that and square root it again, you can also get your radial RMSE. I took the average of the elevations with my test data and all the data sets I was going to test, and I averaged them, and I adjusted the NED 2013 up 0.748 and the City of Longview up 0.350 in case there was some sort of error with my geoid model or my transformations or projections. I figured, well, at least that would get a little bit that adjustment really didn't have that great of an influence. The City of Longview's RMSEZ for elevation was 0.67 feet, and the NED 2013 RMSE for elevation was 6.41 feet. And if you take a look at the RMSE for Y and X on both of those, they're within 300ths and 400ths. So I didn't use this for any kind of analysis other than this is how accurate I was when I took my test shots to collect my elevation data. Using Esri, I classified the RMSE values as Jinks natural breaks and symbolized with graduated symbols. The NED 2013 had the greatest errors on ridges and valleys, and the City of Longview really didn't have any observable reason for poor RMSE values. They really weren't that crazy anyway. If the City of Longview data set was produced at a flight altitude of 4,000 feet, that would give you an RMSE of less than 0.53, expected accuracy less than 0.4, and a max tolerance of less than 0.80. The City of Longview 2000 dataset was above the RMSE contract requirements, but well within maximum tolerance. And at 0.67, the derived 2-foot contour interval mapping product at 1 inch equals 100 feet meets the NMAS standards and the rule of thumb of plus or minus half the published contour interval accuracy. So focusing on 4 square miles versus 147 square miles, and then also not focusing in vegetated areas to see those errors due to time constraints of this project. The national elevation data 10-meter data set at 2-meter RMSE would be difficult for feasibility projects other than general location of terrain features. It shouldn't really be relied upon for any kind of volume analysis or the location of break line features. The field work to test these data sets was very time consuming. I mean, we had to drive to each individual point. It took a while. But the methodology was really simple, and once the data came in the office, the Excel spreadsheet to calculate RMSE was really easy. Most engineers will commission site-specific data collection anyway. So even GIS data sets in application, generally you can get higher accurate data sets, but using these methods, other GIS data sources can also be checked for accuracy. Thank you.